Welcome, ladies and gentlemen. We're going to study what's called conformations right now. What is a conformation? Well, it's the way a molecule appears at any given instant in time as its bonds are freely rotating. I know that's a lot of words. Here is the molecule that we're looking at. I believe if you're looking at it, and I'm going to stop sharing the screen so this gets a little bigger for everybody. I'm holding the methyl group on carbon 6, I'm pretty sure. And there's a hydrogen on carbon 5. Here's the bromo on the ethyl. Are you seeing it on your little handout here? I know it's a very big object. It's very scary, especially with me behind it. All right, well, we're just going to draw it, and we're told which carbon is going to be in front on our little activity today. What number? 6. Is that the one with the hydrogen on it, or the one with the bromo ethyl? With the hydrogen. Okay, so I'm holding 6. We're told we have to have our eyes looking this way. Don't worry if you're having trouble seeing this. I'm going to share it over here. You are told in the question that you must be looking this direction with your eye. Here's my lame attempt at drawing an eye. I know, it's pretty lame, man. It disappeared. Here. So, this is intimidating. If you're like me and you're asked anything about spatial representations of molecules and converting from looking at the side of the molecule to looking on the end of the molecule, you're scared right now. I would be. I didn't have a teacher who done it a lot of times and figured out some tricks for their students. Okay, that's what we're all about. So I'm going to do a little weird exercise here. And I'm first going to draw a circle, because what a Newman projection does is it looks at one of the carbons in front, and that's the carbon you see. That one is 6 right there, and every one of them is going to have 6 in front. And the question is, how do we draw the wedge and the dash? I do know how to draw this bond to H, and that will be the bond I draw first. And I strongly suggest you do the blue parts first. And the H is not a wedge. Wedge means sticking out of the page, right? Yeah. It's not a dash. That means sticking behind the page, right? So how the heck am I going to draw it? It's not a wedge, not a dash, and it's definitely below my eye. So if I'm here, it's not a wedge, it's not a dash, it's there. That is straight ahead and down. Okay, it's a line, good. It's not going to be a wedge or a dash, it's going to go straight down. Always draw the bond that isn't a wedge or a dash first. It's just a good strategy. And I'm seeing it, and there, wow, that's a little long. Try to keep it in the box, although I will not be able to keep this in the box, just too exciting. Okay, and now this little exercise I'm going to do to help you out. This is going to probably be weird on the video. And this morning didn't work out as well as I thought, but maybe this afternoon a little better. Okay, I'm told I have to stand right here, right? And look right there. The chair was there this morning because I had it up on the top of the screen. I figured something out this morning. Okay, so the only question I have for you is, for this wedge, do I use my left hand or my right hand? That's it, right? That was my left hand. That's the only answer. Now, was it a little above my eye or a little below my eye? Above. So left hand a little above my eye, but not straight up. No. Straight up is something like that, right? Okay, so left hand a little above my eye. Remember that. That's reality here. Okay, so left hand and the group CH2, CH2, C with a diethyl. Okay, we'll put that in red. We'll circle it in red. Left hand, slightly above my eye, CH2, CH2, C with an ethyl and another ethyl. There's that group in red. Now, do I have to go back over there and ask you the question, which hand do I have to use for the dash? Please don't make me go back over there. It was my left hand to get in front of the screen. What hand will I have to use to get behind the screen? I'm here and it's there, okay? Right hand and a little above my eye again, right? Definitely above my eye, the stash. Did I say draw this on the right and then I went and drew it on the left? Just say yes. Dr. Whitaker has trouble speaking and doing things at the same time. We know this already. I drew it on the left. I was supposed to draw it on the right. I said on the right. I did say on the left. Okay, I'm losing my mind. Please forgive me now. It's hard following this guy sometimes, yes. You know, I got the morning lecture where I had them standing on the other side, and that's still in my brain because it wasn't that long ago. Okay. So it was my left hand, we agree. I can walk over there, use my left hand. And it's my right hand for this other one. And it goes CH2, CH with the diethyl, and I'll put that in, I don't know, purple. This group's in purple. Slightly to the right, upwards, CH2C with an ethyl and another ethyl. Beautiful. Now I should have done the other bond that wasn't a wedge or a dash, but we have a question first.
Yes, so the groups, why we don't just make a line? I've done the group, why not us to go other group?
Because we have to get good at interconverting stick figures and condensed and back and forth and back and forth. This will save you a lot of time, so please don't be drawing CH2s, CH3s, parentheses, and all that stuff. Go straight to stick figures, spend the time, get the practice, do it now. Because you're just resisting something that will save you later. And then you're just creating a nightmare for later, because now you gotta, I screwed up, I should have really learned it the first time. He told me that day in class. Okay, all right. So, I should have drawn in blue this group here because I have to draw the three things off of 5 as well. And that's not a wedge or a dash. That's why I should have done it first, right? Because you don't have to use left or right hand. It's just straight above your eye. So that methyl in blue is right there. Okay? And then we'll go and ask which hand. I will not walk over there again. But which hand is going to have to be used to grab the dash? Well, it's on the same side as the other dash, same side of the page, right? That was my right hand, and you remembered correctly. That's right. I'm standing there. Everything on a dash is to my right. Everything on a wedge is to my left. So, and the other question is, you said it's my left hand. I agree. Now, is it a little above your eye or a little below? Definitely below your eye. So, right hand below my eye. And remember, people, things need to be evenly spaced when it's drawn like this. So I'm going to put it in light pink with my right hand, and it goes right in between those two groups there. There's the BR, and there's the rest of the ethyl. And then this group here in orange would have to be my left hand, and it goes CH2, CH2, C, CH2, CH2, C with a diethyl. Very nice. All the hard work was done in the first molecule. If you did that molecule right, you got a great chance of getting quicker points for the rest. But before we go get those quick points, we have to learn a word. And the word is this one. Bulky groups are branched closest to where They are attached. What does that mean? Let's get the methyl out of the way. It's not bulky at all. It doesn't have any branches. It doesn't have anything else except for one C. This thing, the C that's attached to the chain, has two things on it. It has a methyl and a bromo. They're both pretty big. I've got them here. I think you'll be able to see that. Bromo is just a little bigger than a carbon, but this carbon has 3 H's on it too that aren't shown, right? They're both pretty big. Whereas a methyl, there's nothing big on a methyl. This one's bulkier, the branched one. And the branch is right there. This one over here has a branch too, but it's way away from where it's attached. That means it can swing its tail. Did I tell you sigma bonds are always rotating? I don't think I did. I am now. So this thing just takes that little tail and gets it all out of the way so it's not near anything. There's no steric hindrance. That's when groups are close in space. That would be when this swung over here and it's like almost touching these things. But this thing can swing away, so there's no steric hindrance. This thing, when it tries to swing away, that one swung in, so let's swing it away. Oh, but that swung the methyl in towards things. So when you're branched, you can't swing both your groups away. When you're branched far away from your attachment, you can swing the whole branch away. So of those three groups, methyl, bromo, ethyl, and I guess this would be 3-ethyl pentyl, which one has the branch closest to the ball? Remember, a bromine is pretty much like a carbon in terms of size. So this is the one, right?
Yeah.
So I'm going to circle the bulkiest in baby blue. I didn't use that. Bulkiest means, like it says above, a group that is branched closest to where it's attached. So that's the back carbon. C6, front carbon. This is the least bulky. It's a hydrogen, right? That's tiny. Which of these two groups, the purple or the red, has the branch closer to where we're attached? The purple is bulkier because the branch is here. It's harder to swing that away from where it's attached than it is this branch, which is another carbon away. So as it stands, our two bulky groups are how close to each other?
Very.
Pretty close, yes. Bulkiest groups have a dihedral angle, which is just a fancy way of saying, okay, we've got two tetrahedra, a front tetrahedron and a back tetrahedron. That's the invisible carbon, number 6. You don't see it, or sorry, number 5. The carbon behind the front carbon is invisible, but you see the bonds off of it, don't you? So we know it's there. The angle between this group on the front tetrahedron and this group on the back tetrahedron, that's why we have the word dihedral, is what? Right there. What's the angle? Let me remind you that in the big circle, going front to back, there are 6 groups evenly spaced. That's called staggered. What's the angle when they're evenly spaced and there's 6 of them between the adjacent ones?
So does each one have an angle of 60?
That's correct. 60, 60, 60, 60, 60, 60, give 360.
Yeah.
There was 6 60s. Okay. So dihedral angle equals 60 degrees. In the least stable conformation, which would be the last one, you get the bulkiest groups on top of each other. Dihedral angle, DA, dihedral angle, equals 0 degrees. They are right on top of each other. That means they're very close to each other. That means the molecule has the most steric hindrance. That's groups getting close to each other in space. It's a phenomenon that dictates a lot of things like physical properties and chemical properties, okay? And then what about the middle one where we're supposed to draw the most stable? What do you think the arrangement of the bulkiest groups is? They are as far apart as possible. What is the angle between two objects that are as far apart as possible? DA equals, say it again. You are correct. And the question asks us to rotate carbon 5, which is the back one. How much do I have to rotate the back one so that the pink thing is 180 degrees from the purple thing? So 60, 120, correct? It needs to go where the orange thing is, was what I'm saying. Correct? So we're going to rotate 120. Everything gets rotated 120 on the back carbon. You don't need these arrows on your thing. So copy the front carbon, please. Do it twice. Yes, ma'am. Yeah. Oh, I didn't. Yeah, I did change that from this morning's question. Thank you.
What happened?
See, there's not two ethyl groups on there. I believe this morning there was. That's what got me. There's just two methyls, right? It doesn't change our branch, our definition of bulkiest, does it? Because the branch was this carbon right there. And it's still further away than this branch right here. But I'm glad you spotted that still. And we didn't move the orange yet. We're just copying the front carbon, which is 6. Should have done it twice. Oops. Orange 2. That's red. CH2.
So if we're rotating carbon 5, then aren't we just
That's
rotating the blue line?
There's the back. No, you're rotating the whole, everything on that carbon. And then straight down was a blue H. Sorry, they started running into each other here. Now, rotate the pink group. Wow. So it's right here. And wait a minute, no, that was the 180. I did the 180 first. Sorry, that's this one. And rotate, so it's 0, which means I had to rotate bulky to bulky. That'd be negative 60. I didn't draw the arrows for that, but that'll put the pink right here with a bromine and a methyl. And rotate the blue negative 60. Oh, you don't see the whole bond. My apologies. Hope you didn't get that far. You only see the first part of the bond because the ball is in the way of the rest of the bond. So don't make that bond go all the way to the middle like I mistakenly did. You don't see it. It's blocked by the ball. So that's rotating this way. And then the methyl rotated to there. And then let's see, we rotate this to here, and the methyl rotated here, and the orange rotated to behind the H. The orange rotated behind the H.
Does it matter how we redraw the number text, or did you just do that?
1 second. Diethyl. And wait, I think I was talking about, I did that right. And I didn't do anything on this one. Orange went, we're going 120. I'm doing too many things at once is my freaking problem, right?
Yeah.
Yeah, I rotated this way to get them 180, right? By 120 degree rotation. And I should have finished it before I started doing the other one. So rotate that 120, orange 120, we'll put it straight up to the top, correct? CH2CH with a V. And the blue, the methyl group 110 brings it to where the pink was. And I just don't like how this is stopping a little early there. Whew. And to get, see, now the yellow's confusing me. To get the, yeah, I did that to get to here. Yellow gets you there. I just want that to be clear. Doing the yellow will get you from here to here. And if I have gray, I rotated the, to get them on top of each other, I rotated this way. This rotated to here, this rotated to there. Oops, not a back carbon, And gray gave this result. I don't need these, whoa, I don't need these arrows. All I need is the pictures, people. Everything else is just for your education. I just needed the pictures with the groups in the right spot. You don't have any freedom in this question. You are given a representation and asked to translate it to a different, very specific representation. So you can't ask the question, does it matter if this is on the right or the left, the purple and red? Oh, sure it does. You'll have a different molecule if you flip those two. It's not this molecule.
Like how you wrote number 6. Kind of like the way you redrew it.
Yeah, you have to do this question where 5's behind. So the green ball was 6. I don't see 5, but I see the stuff sticking off of it. The methyl sticking off of 5, right there. The bromoethyl off of 5, there. And the isopentyl off of 5, right there. So there's a lot there. That's a good one. Definitely watch the morning video where the only change was I made them look at C6 in front and C5 behind. It changes the whole picture of the question. Even though you're looking at the same molecule from a different angle or different approach, it looks different. All right, here we go.